Thank you. How's all the heroes today? The heroes to be? Heroes in training. Does anyone want a balloon cape? All right. I brought a balloon cape, especially for this event, made by my friend from Pop Designs. It's really fun to try it on and take pictures with yourself, and we've experimented. You could lay on the table and make it look like you're flying, or like do the hero pose. Like, it's really fun. So thank you for that. Thanks for having me here today. I am a scientist. I study the evolution and the brain basis of heroism. All right. So most of the time, actually, in psychology these days, they study the amazing capacity of people to be empathic and helpful. But oftentimes, sadly, we fail to be our best selves, right? This is a famous case on top, Kitty Genovese from 1964, and she was stabbed 12 times. No, she was stabbed in the alley behind her apartment, and at least 12 people, and originally they reported 34 people, heard the event and didn't do anything to help. Didn't even call the police, didn't go out to help her, didn't yell out or anything. And it became like an infamous story of what we call in psychology bystander apathy, when people fail to act. And there's this famous case not too long ago of a girl who was bullied terribly and nobody stepped in to help. And if you live in an urban area, it's inevitable. You pass by homeless people, and oftentimes the most common response is to just avert your gaze and try to avoid the situation, right? Next slide. But on the other hand, there are cases we hear about where people do incredibly dangerous things. They rush into a very potentially hazardous situation for themselves and the other individual in order to help. And these are the kind that you often hear about on the news, when somebody rushes into a burning building or into icy waters to save somebody. And these are kind of a paradox in contrast to these apathetic cases that were much less dangerous and much less costly to the individual, but still nobody helped. How do we explain this discrepancy, and how do we explain why somebody would want to rush into danger seemingly without thinking? They always report afterwards, oh, I just didn't even think, I just rushed in. So I've developed in my research a model that explains this sort of active, heroic kind of altruism as an offshoot of a mammalian nervous system designed to secure the safety of offspring. Okay? So mammals have young, helpless offspring that they have to take care of for a long period of time relative to other species. So there's a response in the mammalian nervous system to rescue, retrieve, and keep close helpless neonates. So if you extend this out to non-offspring, the response can also be elicited in cases that are very similar. Okay? So if the target, the person who needs help, is baby-like, vulnerable, or bonded to you, that makes you more likely to respond. If the target is distressed and in need, it makes you more likely to respond. And if you know what the action is to help the other, if you know what needs to be done, and you think you're capable of performing that action, that especially will promote the action. So when all of these things are in tandem, that's when you're most likely to see the response, because it's most similar to the ancient neural system of the offspring response to babies. So I take a lot of my inspiration from this cool and funny study from the 1950s. They have dozens and dozens, if not hundreds, of these experiments on what they call pup retrieval. So they have like a female rat mother in one part of the cage, and then they put a pup, which is like a little baby rat, down a chute, and it goes whoosh and lands in the bottom of the cage. And then the female runs out, picks it up in her mouth, and carries it back to the nest. And then they take another pup, whoosh, put it down the chute. She runs out and gets it, puts it in her mouth, and drags it back to the nest. And then they keep doing it until there's 6 pups in the nest, which is like a typical number. But then they start taking out the pups and putting them back down the chute. So there's this like never-ending cycle of pups that need to be retrieved back to the nest. And they're waiting and waiting for the female mothers to give up, to get tired, to not care anymore. They did it for 3 hours straight, and the experimenters gave up. The response never got tired, never habituated, and it wasn't even their own offspring. These were unrelated pups to them. So I take a lot of inspiration from this model, and there's a lot we can learn about it. And there's actually, because there's so much research on parental care in biology, they actually know the exact neural system underlying this response. And adaptively, it has an approach arm and an avoidance arm. So just like in the 2 examples we gave at the beginning, you can have bystander apathy in a case where the individual feels scared or doesn't know how to help, or is concerned that they're going to make things worse, or they don't think that they're physically capable of performing the action. You have this avoidance response in the brain and in the behavior. But if the individual has like a bond with the other, they're familiar, they know what to do, they feel competent, they're not scared, then this approach response predominates. So it's actually adaptive, but it explains why we have these discrepant cases of seeming apathy, but also, heroism when somebody feels competent in the moment. And then you can expand this rodent model with the things in the circle that are like human brain areas that have expanded in recent evolutionary history, like in your frontal lobe. And not only that can help you prevent yourself from rushing in when you actually might endanger yourself, but it can also help you give aid to somebody when it's not your first instinct. When you know it's the right thing to do, but you're not reflexively driven to do it, you can use these areas in the circle to help drive the behavior, what we say in psychology, from the top down. In my own research, we have investigated this. We put people in the fMRI brain scanner. Have you guys ever seen one of those? It's like a circle, and then you lay down and you roll back into the circle, and then these super loud magnets go off while you're doing some kind of task in the machine. And then when you do the analysis, it shows colors in the brain areas that are most active while you were doing the task. So we gave people tasks where they had to donate to charities. So there was dozens of different types of charities, all manner of forms of helping. And then you could decide every trial, do you want to give some of your money to that charity, or do you want to keep the money for yourself? And the people were allowed to take the money home after that they didn't donate. So it was somewhat of a real decision. We found, in accordance with this Offspring care model, that people give the most money for the charities that involve babies or children compared to ones that don't, that involve adults. They also give more money if you word the charity to be very active and concrete and immediate, rather than something that's going to happen down the line, maybe that needs help later. But the more you make it like an active rescue, especially of an offspring, the more money people donate. And we also find activation of some of these same brain areas that were discovered in rats in people when they're making the decision to donate to these charities. So just like in the model where you imagine donating isn't just something you do in your head, it's something that your whole body participates in. So you try to help somebody. So even when they're laying completely still in the scanner, you're not allowed to move at all. The entire hour, you have to be completely still. Even though they're not moving at all, and they're just donating money. They're not actually physically helping people. The more money they donate, the more their whole motor system, the parts of their brain that are involved in motor activity are involved. And we also find this cognitive area that's helpful for calculating the costs and benefits of situations and keeping in mind the various attributes of the charities. It's called the DLPFC, that's short for dorsolateral prefrontal cortex. That's also involved when people make decisions to donate money. And there's also an area back here in the parietal cortex that you use to visualize things moving in space. So the people you imagine in the scanner are seeing the movement in space of the person who needs to be rescued, and then it activates this actual physical bodily motor response that you can observe in the brain and in how much money they decide to donate. Okay? So, can you do the next slide? So in this model, not all forms of giving are rescues, right? There's a lot of people who need your help, but they don't necessarily need a rescue. So this very dark circle here in the bottom right, the active offspring care, that's like the rescue, which is a form of altruism, which is a form of helping, which is in this broader class. So there's all kinds of different ways people can be altruistic, and being helpful is only one of those forms. And nurturing and rescuing people in the way that we do for Offspring is only a subset of ways you can help people. Not all forms of help are going to involve this response, but it's an extremely powerful form. So it's something to keep in mind. But we also assume, just like in the experiment I described, that when an abstract situation, like money donation, activates this concept of the helpless person who can't do for themselves, that's distressed, crying, in need, and immediate help, and you know what to do, that increases the likelihood that you'll have this active altruistic response. Next slide. Well, there's one more slide with me wearing the balloon cape, but that's not too important. So I just want to thank you all so much for coming today, and I'm so excited to see all the other talks from our real-life heroes that are here among us and in the wings and waiting to speak. I went to this meeting the first year, and it was so inspirational. Thanks for coming today.